This is video 3.1, and the goal of this video is to review how to solve systems of equations. So first let's remind ourselves, what is a system? So a system of equation is a group of two or more equations with multiple variables. A group of two or more equations with multiple variables. Remember, systems we often use to help us solve real-life problems, because lots of problems involve multiple things going on, multiple variables, and we want to be able to write equations to describe those situations and then solve problems involving them. For instance, when you did the big race problem, when will Joe and Susie be at the same spot? When will they be crossing? And so on. So here are three pairs of examples. So each of these is a pair of a system of equations that we might be asked to solve. Okay, there are multiple equations, so two equations for each of them, and they each have two variables. Okay, so the first thing to understand is, what is a system? And it's a group of equations with two or more variables. The next question is, what does it mean to solve the system? So solving the system, now we're going to mostly focus on two variable systems. To solve the system is to find any points that they have in common. Now we're dealing with two variables, x's and y's, as you can see in all these examples. So that's our goal, is to find the point or points. There could be multiple points, and you'll see that a lot when we get into chapters 9. Point or points that the equations have in common. So we're basically trying to find when are these two the same? And the way we see that we can see that on a graph, but graphs take a lot of time. So we want to be able to solve these systems without using the graph. Okay, so we're trying to find out when they're the same. And so one strategy we have to solve will involve when you have equations that look like example number 1 here. So we have, notice that in both of them they have y alone. This is a prime opportunity to either graph the two equations and see on the graph what points they have in common. Remember, that would be a point of intersection, so the two lines would be drawn and you would see the one point they have in common where they cross. That's a point of intersection. A second option for solving this is what we call equal values, and that's the one we're going to review here because it will take hopefully a little less time. It will also give us exact values in case the numbers happen to be decimals. Graphs are hard to see decimals on. The second strategy that we need is involved when we have cases where the y is not alone. Okay? In this case, we have x alone in one of the equations, but x is not alone in the other one. So we cannot use equal values or graphing very easily. So we're going to use what's called substitution in cases where you have one variable is alone, so one equation has one variable alone. Now this is the case, this is what we're going to use substitution for. We could use equal values, but it would take some extra steps, so we want a strategy that will work a little bit quicker for this particular type of problem. The third example, so that was example 2, the third example is even more tricky because now we don't have x or y alone. Notice all your variables are mixed within your equation. We could solve them for x or y and use equal values or substitution, but a quicker way is going to be using what we call elimination. And this is going to be when no equations have a variable alone. So if no equations have a variable alone, elimination is our option here. Okay, so remember, equal values when both equations have the same variable alone. Substitution is when only one equation has a variable alone, and elimination is when neither of them have a variable alone. So let's go through how to use those strategies in solving these systems. Let's take a look at equal values. It's just like it sounds. We're going to figure out when are these two rules equal. Okay, I want to know when these two rules have the same output for some x that I plug in. Okay, so that's where we could make the graph and look at the graph. But what we're going to do is we're going to ask the question, when does this rule give me the same answer as this rule? And so I'm going to write that equation and solve that problem. When are these two rules equal? And that's where that word, why we call it the equal values. We want to know when those two rules are equal. And now we just solve using our equation skills. So I'm going to add 3x to both sides. So I get 2 equals 7x minus 5. And then I'm going to add 5 to get my x's alone. And I get 7 equals 7x. One last step is dividing by 7 on both sides to see that x equals 1. So apparently when x is 1, these two rules will give the same y value, and that's a point they will have in common. So let's take a look at that situation here. If I plug in 1, I should get the same value, because remember, we're trying to find any points they have in common. So my answer should be in the form of a point, so I'm not quite done with this problem yet. I found x, but a point has x and y, so I still need to find y by plugging in 1 for x. So where x is, I'm going to plug in 1, and I'm going to see that the first rule gives me 2 minus, well, 3 times 1 is just 3, so I get negative 1. Now if I do the same thing for the other rule, I should get the same answer. Remember, I'm putting 1 in for x because that's what I found using equal values. And I get 4 minus 5, which also gives me negative 1. So apparently when I plug in 1 for x, I get a value of negative 1 for y. So this is a point they have in common, and that's the solution to the system. Okay? At this point, you should pause the video. Rewind it and watch it again, the example, if you missed any steps. But try the independent practice problem on your own. And then restart the video when you want to see if your answer is correct or not. So pause the video now and restart it when you're ready to check your answer. Okay, here's the solution you should have gotten when you tried solving this one on your own. You should have gotten 5 for x and 14 for y. If you did not get that answer, check over your work and ask your teacher to help you find your mistake if you couldn't find it on your own. But definitely ask questions now before it gets more tricky in the next problem. The next problem, remember, we're looking at the second example from the sheet, and that's the substitution example. So substitution is just like it sounds. We're going to substitute in and replace something with something that's equal. So the number one thing we have to think about is we have to see the variable that was alone. Remember, this is substitution because one variable was alone in one of the equations. So x, this value x over here, equals this thing on the right. So these two red circles, we'll call them, are equal. They're the same value. Okay, but notice up above, my goal is to figure out when this rule also has the same x and y values. So I want this x value up here to equal these x values down here. So what I'm going to do is substitute in that expression 2y minus 7 in for x. So remember, everything else stays the same. The 2, the minus 3y equals 4 is all going to stay in that equation. But what I'm going to do is I'm going to substitute in for x 2y minus 7. Because it's equal to x according to the second rule. This way I've merged the two equations and I've incorporated both of their rules in one rule using substitution and replacing something that it's equal with. So now I'm going to solve using my equation skills. So let's see, first I'm going to take care of these parentheses and distribute the 2. 4y minus 14 minus 3y equals 4. And I'll continue solving for y. Let's see, I can combine like terms here and get 1y minus 14 equals 4. One more step to solve for y, add 14 to both sides. And I get y equals 18. So apparently when y is 18, these two x values will also be the same. They'll have the same value. Okay. Now I'm going to go back to my equations. Remember, we're not done. To solve a system means to find the points they have in common when we're using two variables like x and y. So we have one point, one part of the point. We have 18 for y. We still have to find x. Okay? Take a look at your two equations. We're always going to be plugging back in to figure out what x is. So we have 18 for y, and we're going to plug it in for y. And I'm choosing the second equation because it just seems like it's going to be a little bit easier to find. So I'm going to do 2 times 18 minus 7. So it's 36 minus 7, which equals 29. So apparently x is 29 when y is 18. Now I'm going to check my answer just to be sure that I'm right by using my other equations. Remember, I used the equation that said x equals 2y minus 7. So now I'm going to use the other equation to double check my answer. And I'm going to plug in 29 for x, and I'm going to plug in 18 for y. And I'm going to make sure that when I do this math, I'm going to get 4 like I'm supposed to. So 2 times 29 will give me 58. 3 times 18 gives me 54, which does, in fact, equal 4, just like it's supposed to. So 29, 18 is a point that both these systems, these equations have in common. Therefore, it's a solution to the system. Once again, try the independent practice question on your own. Remember, you're substituting in and replacing one variable with an expression that has the other variable in it. So take a look at what we did and what we chose to substitute and try this one on your own. Ask your teacher if you get stuck. Pause the video now and check your solution when you're ready. Here's the solution to the independent practice problem that you're trying with substitution. Make sure you ask your teacher if you got it wrong or if you can't find your mistake or you're not sure where to start. Final process is elimination. Remember, this is when x and y are not alone. Nobody's alone. We can't use our previous strategies. So what we're going to do is we're going to merge these equations by adding them together. And the key things here are to line up the equal sign. Mine are already lined up. I can see that they're right on top of each other. And then what I do is I look, because my goal is to add the two equations together. Now the whole point, the reason it's called elimination is when I add together y or x should eliminate completely, meaning have 0 of them. Now when I look at this, it looks like when I add them I'll have 7 x's and I'll have negative 2 y's. So this doesn't help me. Elimination is not quite ready to be done yet. I need to do something to the equations to make it eliminate. So I'm going to go back. Before I actually add them, I'm going to think about if there's something I can multiply by so that the x's and y's, x's or y's will eliminate. And it looks like if I take the bottom equation and I times it by 2, it will eliminate with the top. So I always look for things that are opposites of one another or easy to convert. Because I really want 4y's right here. And I'll get 4y's if I times everything by 2. So let's multiply everything by 2 on left and right. I get 10x plus 4y equals 16. Every single thing gets multiplied by 2. And then I'm going to rewrite the first equation right below it. These are the two equations that I'm going to add together. So remember, you add everything on the left, and hopefully something eliminates. In this case, it will, because I created the y's to make them eliminate. So I'll get 12x equals 12. 10 plus 2 x's, the 4y's disappeared, and it equals 12. 16 minus 4 is 12. One last step, and I have x. So many students like this strategy because it gets you one variable really quickly. Now the second variable is going to take a little bit more work, but it's the same process. That's the good news, is what you've been doing. You go back to your original equations and you plug it in. Doesn't matter which equation, we're going to plug it in. Let's do to this one. 2 times 1 for x minus 4y equals. So I have 2 minus 4y equals negative 4. Continuing to solve, subtracting 2 from both sides, I get negative 4y equals negative 6, and then last step, dividing both sides by negative 4. And I get y equals positive 1.5. So now I have my point of intersection, 1, 1.5. Okay, so elimination can be tricky in that you have to sometimes multiply by something, and in order to get something to eliminate. Okay, so remember that first step. So our solution was 1, 1.5. So remember that first step was taking this equation and timesing everything by 2 so that the y's would eliminate. So that's going to be key here. You always have to decide how to eliminate someone. There's lots of options for this question here. I'm going to let you try it on your own, pause the video, and then restart it if you want a hint on how to solve it. So think about what you want to eliminate, and remember, if we try to eliminate x's here, what would this x have to be? Think about that, and that's what you multiply by. This is the solution that you should get when you're done. If you get stuck, ask your teacher. If you get the wrong answer, get some